Kepler's second law. I will return that the statement of Kepler's second law. Okay. Kepler's second law explained the law of area. The radius vector drawn from the sun to the planet sweep out the equal area in a equal interval of time. The radius vector drawn from the sun to the planet out equal areas in a equal interval of time. That is law of area. Consider that is an ellipse. Usually, the sun will be either one of the foggy, either this side or that side. Let us consider the sun is placed here. Consider any planet moving from one point to the another point, say A. This is the radius. The area swept out in a given period of time, say let it be T. In a given time T, the area covered by this planet from A to B, this area, will be equal to the area swept by the same planet in the same time. Consider another point of that planet coming from C to D. To move the point from C to D, the time taken is, say, T. The area covered by the radius vector will be equal. There is a statement. அதாவது ஒரு planet A ல இருந்து B க்கு travel பண்ணுது. அப்போ அது கவர் பண்ற ஏரியா for the given time T, அதே டைம்ல இந்த planet C ல இருந்து D வரைக்கும் to move the point from C to D, the time taken T. If the time taken is same, the area swept by the planet when it is moving from one point to the another point will be equal. That is the law of area. The statement is the radius vector drawn from the sun to the planet will be equal for the same time period. Understand? Rate of change of displacement is nothing but a velocity. Here, rate of change of area is nothing but the aerial velocity. Understand? dA by dt is aerial velocity. Okay. Now, another important point about this Kepler's second law, angular momentum is conserved. Angular momentum is conserved. Write down this angular momentum. Angular momentum is denoted by the letter L. The angular momentum in terms of aerial velocity 2m dA by dt. Angular momentum in terms of aerial velocity is equal to 2m into dA by dt. Next point. Area covered by the planet in dt second. Area covered by the planet in dt second is equal to half r squared d theta. D theta is the function. This is the area. Therefore, this can be written as aerial velocity. Aerial velocity means dA by dt. This is the area, dA. When it is divided by dt, it becomes aerial velocity. Therefore, half r squared dt by, sorry, d theta by dt. This can be written as r squared. Rate of change of displacement is velocity, that is a linear velocity. Rate of change of angular displacement is called a angular velocity. Therefore, d theta by dt can be written as omega. What is the relation between linear velocity and angular velocity? Linear velocity is equal to omega into angular velocity. Now substitute over here half r squared instead of omega. What is omega here? V by r. Substitute over here. Sorry, V by r. R get cancelled. Finally, it becomes half V r. Therefore, this formula is in terms of linear velocity. This formula is in terms of angular velocity. This formula is in terms of what? Angular displacement. All are important. Note down this, please. Angular momentum in terms of angular velocity 2m dA by dt. Shall we go to the next law, students?
Yes, sir. Yes, sir.
Okay. Kepler's third law is also called law of period. First law is called as law of orbit. Second law is called law of area. Third law is called a law of period. According to this Kepler's third law, the square of the time period, the square of the time period of the revolution of the planet is directly proportional to the cube of the semi-major axis. Cube of the semi-major axis. I write the statement. Kindly take down this. The statement, mathematically, it can be written as square of the time period. That is t square. Square of the time period is directly proportional to the cube of the semi-major axis. Consider this is the ellipse. This is the major axis. Major axis, let it be 2a. Half of the major axis is a. Therefore, t squared is directly proportional to a cube. The first class, we discussed about the law of gravitation. Correct? That is F is equal to minus G m1 m2 divided by r squared, where G is the universal gravitational constant. M1 m2 are the masses between the masses. R is the distance between the two masses. Have you copied, students? Shall we move?
Yes, sir. Yes, sir.
In the first class itself, I explained the difference between gravitation and the gravity. Gravitation is the force of attraction between any two bodies in the universe. Whereas the gravity is the force of attraction between the earth and the body lying on the surface or above the surface. Understand? Understand the difference between gravitation and gravity? Okay? Okay. The gravity value varies with respect to the distance from the surface of the earth. It will be maximum at the surface, and the acceleration due to gravity will be going on decreasing from the earth. எர்த்துக்கு மேல போக 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 இந்த ஆக்சலரேஷன் கிராவிட்டி கம்மியாயிட்டே வரும். அதே மாதிரி எர்த்துக்கு கீழே போறப்பையும் கம்மியாயிட்டே வரும். அப்போ it will be a maximum at the surface. Now we are going to discuss the variation of acceleration due to gravity depends upon the height or position. Understand? Actually, F is equal to, what is the formula? G. Apply that formula between the earth and the mass. ME small m divided by r square. Basically, we know that force is equal to mass into acceleration. Okay. Now, this formula, can we equate this value as A? Compare these two. And this one, M. This is equated with G. Understand, students? Therefore, acceleration due to gravity therefore G is equal to minus G capital M divided by R squared. When you compare this formula with the standard formula, we can equate the acceleration as G with this quantity. For remaining value in the mass. Therefore, G can be equated as acceleration due to gravity minus G capital M divided by R squared. Understand, students? Where Gm means mass of the earth. Mass of the earth. It is further equated as Gm. Here R is nothing but the radius of the sorry. Kindly note down this. Acceleration due to gravity is minus capital G me divided by Re whole squared, where R is the radius of the earth. See, another important point related to acceleration due to gravity, note down this point. The value of G varies with respect to altitude, depth, and shape of the rotation of the earth. The value of G varies with altitude, varies with altitude, altitude means the position of the mass above the earth, that is called altitude, and the depth indicates below the earth, and the value of G varies with altitude, depth, shape, and rotation of the earth. The G can be expressed in terms of density. How to find out the mass of any body? When you multiply the density with volume, it will be equal to mass, because density is mass per volume. 1 kg, 1 meter cube of substance has a volume, mass as kg. So when you multiply it with meter cube, the meter cube get cancelled, that is equal to me. Therefore, if you want to calculate the mass, you have to multiply the volume with the density. Now, the mass of the earth is expressed as here density into volume. Volume of the earth sphere 4/3 pi r cube. In the denominator becomes r squared. So minus G rho 4/3 pi r e. R squared, here r cube get cancelled, becomes remaining in the numerator as re. This is the another expression of acceleration due to gravity in terms of density. Kindly note down the other point, students. The acceleration due to gravity is independent of, all of you listen here, the acceleration due to gravity is independent of shape, size and mass of the object, but it is depends upon shape, size and mass of the earth. So acceleration due to gravity is depends upon the earth parameters only. It is not depends upon the object parameter. Understand? Write down this value. The value of acceleration due to gravity is independent of shape, size and mass of the body, but have you completed, students?
No, sir. No, sir.
Okay, okay. This is independent of the mass of the body, but it is depends upon the earth parameters or planet parameters. Okay, thank you. Next. Kindly note down these points. All of you listen here. If the radius of the planet, decreases by say X percentage, then the acceleration due to gravity increases by 2x percentage, because provided the mass of the earth is constant. All of you listen here. Radius increase panna denominator la irukku. இது என்ன ஆகும்? டிக்ரீஸ் ஆகும். It is inversely proportional provided the mass is constant. இன்க்ரீஸ் பண்ணா இது என்ன ஆகும்? டிக்ரீஸ் ஆகும். ரேடியஸ் டிக்ரீஸ் பண்ணா இது என்ன ஆகும்? G இன்க்ரீஸ் ஆகும். Inversely proportional provided the mass is constant. Understand, student? When you increase the radius of the earth or body or planet, the gravitation is decreased. Understand? It is based on the formula. பாருங்க, அந்த ஃபார்முலால டினாமினேட்டர்ல RE இருக்கு, G வந்து நியூமரேட்டர்ல இருக்கு. அப்போ இன்வெர்ஸ்லி ப்ரொபோர்ஷனல் வரும். இப்போ இதையும் கம்பேர் பண்ணீங்கன்னா இது ரெண்டுமே டைரக்ட்லி ப்ரொபோர்ஷனல். அதனால ரைட் டவுன் திஸ் கான்செப்ட். The radius of planet decreases by, say, n%, keeping its mass unchanged. Keeping its mass unchanged. மாஸை கான்ஸ்டன்டா கன்சிடர் பண்றோம். மாஸை ஃபிக்ஸ்டா வச்சுட்டு ரேடியஸை மட்டும் என்ன பண்றோம்? டிக்ரீஸ் பண்றோம் by n%. The acceleration due to gravity increases by 2n%. This is simple. n% decrease பண்ணீங்கன்னா radius, the gravity acceleration due to gravity increases by 2n%. Next point. See the formula. All of you listen here, please. I'm going to fix the radius, keeping the radius constant. And if you increase the mass of the earth, the acceleration due to gravity is also increases. If the percentage of mass increases by n%, proportionally, the acceleration due to gravity increases by n%, because both are directly proportional. Understand? Next condition based on the density. If the density of a planet decreases by X percentage, keeping its radius unchanged, acceleration due to gravity decreases by X percentage. Here also the density and mass are directly proportional to the gravity, whereas the radius is inversely proportional to the gravity. Understand? Density, mass are directly proportional, and the radius and the gravity inversely proportional. Students, finished?
No, sir. That's finished, sir.
Okay. Next, we are going to discuss the variation of acceleration due to gravity with respect to the altitude and the depth. Surface, at the surface of the Earth, the acceleration due to gravity will be maximum. It will be going on decreasing when you move vertically upward. Similarly, the acceleration due to gravity is going on decreasing inside the Earth and equal to 0 at the center of the Earth. Now, I'm writing the governing formula of variation of gravitation, acceleration due to gravity with respect to the altitude and the depth of the Earth. Okay. Now, kindly note down this formula. Variation of acceleration due to gravity, in which the first condition is due to altitude. Or height. Surface of the Earth lerundu mele poga acceleration due to gravity decrease ஆயிட்டே இருக்கு. மேல இருந்து surface of the Earth க்கு வர acceleration due to gravity increase ஆயிட்டே இருக்கு. The governing formula, the acceleration due to gravity at a particular altitude, that is a GH. It can be expressed in terms of GME divided by distance squared, means radius of the earth h whole square. This is one fact. Or you can use only G. This formula is okay. Or it can be written as GH in terms of G. That is, a G is the acceleration at the surface. 1 plus h divided by RE minus 2. Using the polynomial theorem, provided when comparing to the radius of the earth, sometimes the height is negligible comparing to the radius of the earth. In that condition, the GH is G into 1 minus 2h divided by RE. The minus எடுத்து இங்க முன்னாடி போட்டீங்கன்னா வந்துரும். Therefore, you have to remember this two formula. This is a general expression. GME divided by RE plus h whole square. This formula is in terms of G. That is acceleration at the surface. Acceleration at any height is the acceleration at the surface into 1 minus 2h by RE, where h is the altitude. Understand? Have I finished? Now, we see the variation of acceleration due to gravity with respect to the depth. With respect to the depth. Consider this is the Earth. This is the center. This one is the radius. Now, let us calculate the acceleration due to gravity at a particular depth from the surface. Say let it be D. Now draw the circle about that point with respect to the center. We are going to find out the acceleration due to gravity at this point, which is at a distance D from the surface. The governing formula is expressed in terms of acceleration due to gravity with respect to the surface. G into 1 minus D divided by RE, where D is the depth from the surface of the earth and RE is the radius of the earth. Therefore, GD is in terms of G. See, this is the formula. If you want to calculate the acceleration due to gravity with respect to the center, measure the distance from here to here. This is RE. Substitute over here in this formula instead of D as RE. RE get cancelled. 1 minus 1 0. Therefore, at the center, acceleration due to gravity is 0. That is at the center means the depth from the surface is equal to RE. Now we can analyze the variation of acceleration due to gravity with respect to the altitude and the depth. How it varies in terms of distance. The variation can be plotted in graph. Say G dash is acceleration vertical axis due to gravity. The horizontal axis, x-axis, is taken as the distance in terms of, say, R. Consider this is the origin point, that is the center of the earth. Take this point, that R is equal to the radius of the earth. At the surface of the earth, the acceleration due to gravity will be maximum. When you go inside the earth, its value is going on decreasing linearly. Therefore, it will be a straight line. Therefore, inside the earth, the acceleration due to gravity varies with respect to R. Distance increase height to maximum surface level. When you proceed further from the surface above the earth, the acceleration is going on decreasing. The acceleration due to gravity varies inversely proportional to the radius squared. This graph is very important. At the surface, it is maximum. Inside the surface, it is going on decreasing and 0. It is a linear. A straight line. That is why it is called a straight line. Here, above the surface, it is proportional to the distance squared. This is inside the earth, this portion above the earth. Understand the student? Understand the concept? Yes. So far, we discussed the variation of acceleration due to gravity above the earth and inside the earth. Another concept, on the surface of the earth, the G is not constant value. It will be vary with respect to the position. We are taking the two reference. One is at the equator, another at pole. Let us calculate the variation due to the Earth rotational axis. Acceleration due to gravity varies with respect to the altitude, with respect to the depth, and the third governing factor is due to rotation of the earth about its axis. Say this is the earth. This axis is equator. Say this point is pole. Let us take a reference point here. Angle made, let it be lambda. The acceleration due to gravity, due to the rotation of the earth, varies along its surface with respect to the angle subtended. That is called the latitude. Gravitation due to the rotation of the earth. See this formula, it varies with respect to G and the position, that is a latitude. Consider the not altitude, latitude. Kindly change this word. Latitude. Omega is the angular speed of rotation of Earth. This value is equal to 7.3 into 10 to the power of minus 5 radian per second. have to memorize this value 7.5 into 10 to the power of minus 5 radian per second. Now, students, all of you listen here. See, this formula is the function of latitude, that is the angle. When the point, this point, say P, is coinciding with the axis of the equator. All of you listen here kindly. See the board. When the point P is coincide with the axis of equator, the lambda becomes 0. Okay, lambda 0. Substitute the 0 value over here. Cos 0, what is that? 1. Cos 0, 1. When the point P is coinciding with the pole point, lambda becomes 90 degree. Understand? Cos 90, 0. Cos 90, 0. Therefore, this governing formula, general formula, is applied at the position of the equator and pole. At the equator, lambda is equal to 0. When you put lambda as 0 value, cos 0, 1, this quantity becomes 1. Therefore, the remaining quantity, that is GH, is equal to G minus RE omega squared only. Next step, at the pole, lambda is 90 degree. When you substitute the value of 90 degree over this formula, all of you listen, cos 90, 0. Suppose the whole value becomes 0. Therefore, GH is equal to G. Comparing these two values at the equator and the pole, which one is greater value? At the pole only, the G will be maximum. GH will be maximum, important point. At the pole. G order some quantity is subtracted. Therefore, automatically this equation, this value is reduced. GH will be minimum at the equator. Equator minimum mark, pole maximum mark. Rendu point value, it lies between minimum and the maximum. Understand, students? So, kindly note down these points.